Good morning, everyone, and welcome to our FortiGate Info-Byte, which is the Fortinet Zero Trust Network Access Internal Segmentation. My name is Adriana Jaleska, and I'm the Events and Communication Specialist here at Wavelink. Today, our webinar will be hosted by Kieran O'Brien, Wavelink Fortinet Enablement Lead, and Kieran has more than 5 years experience in the IT industry and technical sales. Kieran is ECHA certified and is building his Wi-Fi expertise while developing his specialty in the SMB market and secure brand solution. Joining Kieran today is Brendon Schodel, Wavelink Fortinet pre-sales engineer. Brendon has spent the last 8 years in the industry focusing on integration with Fortinet and other technologies. He has a proven track record delivering high-end solutions from data centers to SMBs. Brendon's focus is to connect with and empower Fortinet partners by mentoring and delivering enablement and training, as well as assisting Wavelink partners to be the best version of themselves in a competitive market. Today's webinar is part 2 of a series of 3, where we will delve into Fortinet's Zero Trust Network Access offerings and how to integrate them into your organization. Today, we delve into how Fortinet's Zero Trust Network Access helps organizations meet today's heightened security requirements while ensuring users are authenticated and verified before they are allowed to access applications. If you have any questions during the webinar, please share them in the chat box or the question box, and we will strive to answer them at the end. I will now hand over to Kieran to begin this lovely webinar.
Thank you so much for the lovely introduction. Welcome everyone. Hopefully everyone's doing well this lovely Wednesday morning. As Adriana said, we're going to go through and have a look at how ZTNA helps resolve our internal segmentation issues. So we'll delve into the current landscape and what we typically see out there in terms of internal segmentation. We'll have a look at the ZTNA solution and the different components that make up the ZTNA solution. We'll then pass across to Brendon, and Brendon will then roll through and show you exactly how the ZTNA solution works and go through some of the key features of the Fortinet ZTNA solution in terms of internal segmentation. We've also got a little bit of a demo to show you guys as well during there, so make sure you're keyed in and we'll show you firsthand exactly how ZTNA works for internal segmentation. Then we'll jump back across to me and we'll have a look at some of the ordering options, licensing, and some of the SKUs that will sort of help you guys figure out exactly what you need to order to get the ZTNA solution. And then we'll have a look at where to find some further details. There's a Q&A section right at the end where we'll make sure if we haven't answered any questions that come through the Q&A section in GoToWebinar, we'll make sure to bring them up in live format, and Brendon and I will sort of work through them for you guys. And then we'll quickly have a look at what would be the next steps for you guys to continue down this journey for ZTNA. And at any time, if you have any questions, please feel free to chuck them through in the questions section. So just quickly before we jump in, just wanted to take a minute to say welcome to Wavelink in case any of you haven't dealt with us before. We are a product intimate distributor, and we're very focused, and we've got a very narrow vendor portfolio, and we do that to try and support not only the technologies that we distribute, but also try and support our partners. And we have a massive internal focus on ensuring that we do continue to support our partners as many ways as we can. And some of those ways are doing through a range of specialized marketing campaigns that we can run. We also have services on offer to our partners, such as professional services, staging, rollout, and installation services. So if you want to get a little bit more information about exactly what we can help you with, please do let me know, and we can sort of go through and show you guys, what the benefits are with working with Wavelink. So let's just jump in and have a look at some of the sort of current deployments that we see for internal segmentation. So 3 techniques that are quite commonly put out there are the multi-subnet per interface or flat network design, where essentially you've got multiple IP subnet networks on the same broadcast domain. You've then got network designs that include VLANs, in which case there we're separating the IP subnet networks into different broadcast domains. And then also we're seeing quite predominantly out there, dynamic switch port policies being used in conjunction with VLANs, where essentially what you're doing is instead of manually assigning the VLAN on your switches, you're letting your switches decide what's the most appropriate VLAN to apply, depending on a set rules that you have for it to go through and understand, okay, what's connected, what VLAN should I be providing? Let's jump a little bit further into that first one that we talked about, which is the multi-subnet per interface or flat network design. So with this design, there are multiple IP addresses for the network that are used within a single broadcast domain, typically coming off of a single interface on your router, or sometimes in some network designs we see multiple interfaces used connected down into just a straight flat network. Now, while this does make configuration of the network extremely simple, thanks to not requiring any special configuration on any of the switches on your network, it does have significant security and performance implications for your customers. And the first is because everything is on the same broadcast domain, when PCs or network devices connected to this network send out a broadcast, that broadcast is then sent out to every single device on that network, regardless of if it belongs to the same IP subnet. So in the example we've got on the screen, you can see that we've got two PCs connected in to a 192.168.1.0 network, and then we've got a server that's on a 192.168.2.0 network. Now, if one of the PCs sends out a broadcast to the network, this broadcast will be sent out to everything on the network because it's all within the same broadcast domain. Now, this means that you could potentially get a situation where you've got significant performance implications because a lot of these broadcasts are being sent out to devices that really don't need that broadcast. So for example, the server doesn't need a broadcast that the PC is sending out because it belongs to a completely separate IP subnet mask. Now this takes up a whole bunch of resources. Luckily now switches are getting faster and faster, so we're seeing this sort of become a little bit less of a problem in terms of performance, but it is still a major issue, especially if you're expanding out your network and we start to look at bringing things like IoT devices into the network. Now, the second major issue with this is security. Again, thanks to everything being on the same broadcast domain, there is little to no security between the IP subnets, as traffic is either not routed through a firewall or there's very little security policies that are implemented. And in most cases, if I were to take one of these PCs, change its IP address to belong to the server network, maybe give it the IP address of 192.168.2.10, then suddenly my PC is on the same IP subnet as your servers, and you can get direct access to those. So this whole idea of a flat design is really, really not up to today's standards. There are a lot of security holes with it. It's just plain, not really a good design for modern networks. So then to alleviate this, most networks will then utilize a VLAN design. So with this, what we're doing is each IP subnet belongs on a separate broadcast domain. Now, this does make configuration of the network a little bit more complex than flat design, especially given that most switches are only capable of doing 4,096 separate VLANs. But this design does have significant security and performance improvements over your flat network design that we just saw before. So the first is because each IP subnet is now on a separate broadcast domain, when a device sends out a broadcast, that broadcast is only sent out devices within the same broadcast domain or within that same VLAN. So in the example that we had before, we had a PC sending out a broadcast and then the server was able to receive it as well. Because the PC and the server are on two separate VLANs in this example, the server will never get the broadcast of the PC unless you're specifically putting into your firewall a rule that allows broadcast to be transferred across from one VLAN into another. So you're significantly reducing down your broadcast domain, and that significantly reduces the amount of performance requirement from your switching perspective. It also reduces down the amount of traffic going across most of your links as well. Now, the second is, again, thanks to that separation of your subnets and broadcast domains, for traffic traversing from one subnet to the next, it is now required to be routed. Now, this can be done either by a router or via a layer 3 capable switch. And this allows network administrators to have security policies defining access control, threat prevention, and the ability for them to have visibility of traffic going across your network segments, across your VLANs. Now, the main disadvantage of VLAN networks for most typical customers is that each access VLAN has to be manually configured for each port on the network switches. And each time a different device is connected to a switch port, a network admin will then typically have to jump into that switch and apply the correct VLAN for that device that they've just connected. Now, depending on the deployment and the customer, sometimes this is not an issue and networks are quite static, so it's very rare that we need to actually go through and change the VLANs. But some customers have really, really dynamic networks, and this setup just doesn't quite keep up to that pace because that network admin has to jump in and change that configuration each and every single time, which has a massive amount of administration overhead. So then to try and tackle that, there's this whole design of network switch port policies. And this is essentially to try and reduce that administration overhead. Now, most vendors, Fortinet included, offer dynamic switch port functionality where the appropriate VLAN for each port is automatically selected based on a set of criteria, either by the switch or by the device that's controlling the switch. Now, each vendor has differing options, but the most common criteria for this solution are MAC addresses or hardware vendor IDs and the device type. And using these options, we can adjust and specify exactly what VLAN should be provided to these. So for example, you could have the vendor Dell. Dell might be your supplier for PCs. And you could say, whenever you see a hardware vendor of Dell, place it onto the data VLAN. And let's say you use Lenovo for your servers and specifically only for your servers, then you could choose, Lenovo devices are assigned to your DMZ VLAN, for example. Now, depending on the vendor, this functionality can be extended out to other things. That sometimes includes being able to apply an LLDP, QoS, or 802.1x port security profile to each port, again, reducing that amount of administration overhead. And what that sort of looks like in the real world is, in this example that we've got on the screen is, if I unplug that PC in the middle, which is 192.168.1.11, and then I decide to plug in a server back into that switch, the switch will then recognize, okay, my configuration have changed, the device at the other end has changed. Now let me try and understand what that device is and apply the correct VLAN. And because it's identified this device as a server, it will then go through and apply the correct VLAN to that device, which would be in the 192.168.2.0 network. Now, this all helps you significantly reduce your overhead, but it still may not be the perfect solution for all customers, as it typically doesn't allow for a dynamic list of criteria to be passed to it. Now, we'll explore how ZTNA actually helps bring the ability and the availability of dynamic lists into this functionality by using ZTNA tags to understand what is the device that's connected on the other side and what VLAN should I be provided directly to that device. Now, ultimately, why should we care about taking it any further than what we've seen? So digital transformation is driving business growth and it's enabling new efficiencies. However, aspects that make this growth possible, such as mobile computing, like BYOD, convergence of IT and operational technology requirements, allow for this improved business growth and efficiencies, but it also makes achieving end-to-end security quite a difficult task. Also, maintaining a robust security posture that implements consistent security profiles across all of your network environment is increasingly challenging. We're seeing that from all different vectors, right? Having a flat network that we saw in the first design where we build on a trusted philosophy is really not up to today's standards, and it makes it easy for cyber criminals to get inside the network. And once they're inside, they become part of that trusted zone, and they can access the whole of your network. And this allows them to quickly spread threats laterally, and it's extremely hard to detect and contain these cyber criminals as they move deeper and deeper into your network, which sort of results in a bit of a cascading risk and effect to your customers. So to help businesses, Fortinet has a very diverse and comprehensive solution called Zero Trust Network Access, which aims to help companies overcome the network trust and access policies that they're seeing today and help them move towards a really secure solution. At a very high level, ZTNA provides a better access control solution than your traditional network segmentation solutions, while also providing a layer of protection for when businesses move towards cloud-based applications, because this solution that we're talking about is very, very flexible when Brendon goes through and he shows you. Now, leveraging FortiOS and FortiClient, ZTNA provides that granular control to applications and allows us to do device posture checks and dynamic access policies, something that the existing solutions don't encompass. Now, ZTNA applies zero trust principles to control that user access to applications and services, ensuring that devices are meeting your security or identity requirements before that access is provided. Now, what are zero trust principles, you may be asking? Well, zero trust abolishes the idea of a trusted network inside of a defined corporate perimeter. ZTNA mandates that enterprises create micro perimeters of control around their sensitive data and assets to gain visibility into how they use that data across their ecosystem, whether that's on-site, databases, or whether it's in cloud solutions. Now, ZTNA is a security strategy that has three core principles, and those are never trust and always verify. This is not only where first-time authentication happens, but continual verification and identification happens for each and every session. We've got minimal access, which provides users only with their required access based on their privileges, and it's only to systems that they require to be able to perform their jobs. And then the third, which is assume breach. This is where zero trust principles actually apply, and it's all about implementing security solutions and policies pretending that you've already been compromised and that security measures have been taken if compromised. So essentially, connecting from a particular network must not determine which services you can access. Access to services is only granted based on your identity and your access roles. Now, the Fortinet ZTNA solution utilizes at a minimum the FortiGate, which is Fortinet's next generation advanced firewall, FortiClient ZTNA agent, which is Fortinet's fabric agent. This delivers protection, compliance, and secure access in a single lightweight client. And then there's also FortiAuthenticator, which is Fortinet's powerful access management and single sign-on authentication solution. Some of the advantages of Fortinet's ZTNA solution before we jump further and I pass it across to Brendon are that it leverages your existing FortiGate firewall. So if your customer already has a FortiGate firewall installed, then you can start to look at implementing these ZTNA solutions right away. It extends the security of the FortiGate to protect users wherever they are. So when you're implementing your internal segmentation, there's also the opportunity there for you to look at utilizing ZTNA for remote access and extending that protection not only internally, but also externally. ZTNA is not a licensed feature of FortiOS and FortiClient. It's a part of the base products, and it's just a feature that needs to be turned on and configured. It also allows for simplified management and reporting thanks to the integration with the security fabric. And the last point is it's really easy to transition from your existing internal segmentation solutions across to utilizing ZTNA for your internal segmentation. So with that, I'll pass you across to Brendon and we'll dive in and have a look a bit deeper about exactly how Fortinet's ZTNA solution works. Across to you, Brendon.
Thanks, Kieran. That was a very good presentation. Now, I just need to take control of the screen. You able to share it to me, please? Thank you.
There you go.
Making sure I get the right one. Okay. So I'm going to take you through how ZTNA works. Now, there is a bit of a flow that happens with ZTNA. And the first step is a user attempts to establish a connection to an application. So that application could be an internal website, for instance. And this is automatically sent to the access proxy. The access proxy then creates a secure tunnel, authenticates the user, and identifies the device and if it meets the posture requirements. The access proxy then verifies the user has the rights to access the destination application. If the check is successful, the connection is allowed and the user is granted access to the application. The user is none the wiser. The user doesn't know any of this is happening in the background. They just presented with the application at the end. If access is denied, the connection is just terminated. Each time the user attempts to start a new application or refreshes a page, the whole process is followed again. So behind the scenes, there's a couple of things that happens. The first one is the policies are pushed out from EMS. So FortiClient EMS is the management server, and those access proxies and servers and applications are pushed out to the clients. There's also telemetry from the clients that also gets sent to the EMS server. That telemetry is then synchronized with your infrastructure on site. So that's your FortiGates, and that could be in the cloud, it could be on site, it could be in public cloud. It's really up to you. These FortiGates can then act as the access proxies and allow access to the applications behind them. FortiAuthenticator is used to authenticate the users, and this could be using any form of authentication protocol, which could be LDAP, it could be SAML, it could be Radius. The choice is really yours. The FortiGate proxies the HTTP and TCP traffic across secure TLS connections with the remote client. This enables seamless access from the client to the protected servers on-premise, data center, public, or private cloud, without the need of forming an IPsec tunnel or an SSL VPN tunnel. It's basically just creating a tunnel over HTTPS. So there's a few different components. So the FortiGate is the access proxy that contains all the access rules, authentication schemes, and ZTNA rules are created to control and access the protected applications, and is acting as a proxy to enable remote connections. FortiClient EMS is used to create, manage, and monitor tagging rules, as well as being responsible for signing endpoint certificate requests and reporting those certificates, tagging rules, and endpoint compliance status to the FortiGates. FortiClient is responsible for constantly checking if it matches the rule sets assigned to it by EMS, and if any match, to then report back to the FortiClient EMS. FortiGate and FortiClient are then responsible for establishing encrypted tunnels for HTTP and TCP traffic, verifying endpoint client certificate, and providing continuous posture checks. FortiAuthenticator then provides the network's FortiGates the ability to centrally check user identity with a range of external services such as LDAP, SAML, Radius, could also be FortiClient single sign-on, whilst also providing two-factor authentication. So we can also use the Forti tokens with FortiAuthenticator with this process. So tagging rules help capture the security posture of the endpoints by assigning ZTNA tags accordingly to the rule sets that you create. So ZTNA policies then utilize these tags to perform posture checks and grant access to applications. Tagging rules can be based on many endpoint factors, with availability rule sets with available rule sets different for Windows, Mac OS, Linux. You can also do iOS and Android devices as well. And on this slide, we are checking, if there is any antivirus software installed and running, and or if the OS version is Windows 7 or Windows 10. And if it is, then we can apply that tag. So you can see in this tagging monitor that we have one matched client, and you can see that it shows the operating system, the IP address, when the tag was matched. It also shows the endpoint name and the user. So that's a very handy monitor to actually see all your machines and which tags are matched, which will be more important later on. So in FortiClient can also display these tags. Now this is you can disable this setting so users can't see what tags they are matching. So you can see in this screenshot, there is a malicious file detected. You may not want the user actually seeing that tag, so you might disable it. Or you could enable it to make it easier for support to identify what tags are actually matched. So this is a screenshot of the FortiGate, and you can see there are both IP and MAC address tags that are available for every device. And these are used for identification and security posture check to implement role-based zero trust access. So this screenshot actually shows the MAC tags, but in the demo that I'm going to do shortly, you'll also see the IP tags. So this is the screenshot of the firewall policy that we can create with the ZTNA tag. And you can see that it's integrated with the existing firewall policies for simplified management. And in this box, we can use either the IP or the MAC address, depending on obviously your traffic flow. We can select many ZTNA tags. We're not just restricted to one. So this is an all box. We could select, this one says on-site staff, but we could also select, is antivirus running? And we can use these also in deny policy. So it doesn't have to be just accept, it could also be a deny. So you can utilize these rules with or without ZTNA tags just as normal. And this can be used to apply different security profiles, schedules, protocols, etc. And you can see in this screenshot that the rule with the ZTNA tag, we're also applying deep inspection, whereas the one without the ZTNA tag, we're not. So we can also use FortiSwitch network access control with ZTNA. So similar to the switch dynamic port policy functionality, but we can use ZTNA tags to apply a VLAN or apply, or assign it to a dynamic address object. And they can then obviously be used in firewall policies as well. You can also configure a FortiSwitch network access control policy within the FortiOS that matches that device. So this is all done on the actual FortiGate. It's not done on the switch itself. Devices are matched and assigned to that specific VLAN or POL policy, and we can bounce that port so that that setting obviously gets applied dynamically. We can also assign the correct network behind a FortiAP, so it doesn't have to be just wired, it can also be wireless. And this allows us to broadcast a single SSID and have multiple networks behind it. This functionality is only available on tunneled APs, it's not available on bridge mode APs. So just something to keep in mind. So this is also a monitor on the dashboard that you can have that shows you the matched devices that have been matched to the NAC policy on the FortiSwitch. And you can see that it shows the VLAN, it shows the policy that it's matched against. You can also see whether it's wired or wireless. This particular screenshot is showing you the switch that it's connected to and the last switch port that it was connected to. And we can also see that it's assigned a VLAN to it. So that's using dynamic VLANs. We can view some statistics on the dashboard as well. So how many devices are connected. We can see the assigned VLAN. So that could, in this instance, there's 2, but there could be more. We can also see the users that have signed in, and we can also see whether they're quarantined or not. And this chart can obviously be expanded to give you even more information. So I'm going to show you a quick demo as well. So as you can see here, I'm trying to access Netflix, and my FortiGate has blocked my Netflix access. So if I have a look at my firewall policy, you'll see here that I have a deny rule for Netflix. Now I've done that on purpose just to demonstrate it, and I'm blocking it using the web filter. And I am actually matching a ZTNA tag. So the ZTNA tag I am using is AV is running. Now I have specified that on my EMS server. So if I have a look at EMS, we go to my ZTNA tagging rules. I've created this one called AV is running. And I'm matching whether my antivirus software is installed and running and the signatures are up to date. So I want to know that my antivirus software is actually updating itself. Now, if it isn't, obviously FortiClient will detect that. Now, it doesn't have to be the FortiClient antivirus, it could be a third party as well. So it could be something like Trend Micro or McAfee. The choice is yours, although we do recommend using the FortiClient because it gives you more information to EMS and the other services. You'll also see here that my PC, that I've got these zero trust tags. I've got healthy, antivirus is working, and AV is running. So if we have a look at the tagging monitor, you can see my endpoint. You can see that I'm running Windows 11. You can see my IP address and when it was matched. So if I go back to my firewall policy, I've actually created another one above my deny policy with the same tag that says AV is running, and I'm matching Netflix. But what I'm going to do is just enable this policy and hit OK. So now that that policy is enabled, I should be able to refresh this page and I should be able to access Netflix, which I can. So that's using the ZTNA tag that was assigned to my PC and used in this policy. And because I'm also using my EMS server with FortiClient, I can actually enable deep inspection here and get more information about what I'm doing. So some of the ZTNA key features. So as I just mentioned about deep inspection, so FortiClient can distribute the SSL certificates from the FortiGate to the FortiClients that are managed by EMS. And this simplifies the ability to do deep inspection without having to manually push out that certificate to be trusted. In the past, a lot of companies use Intune or MDM solutions to push out the certificate, but FortiClient can actually do it for you, and it imports it from the FortiGate as well. And you can see this in the screenshot on the left. So the ZTNA access rules for deep inspection that I mentioned before, you can see in this screenshot that because we're using that ZTNA tag on that first policy, we can just enable deep inspection and the clients will natively trust the certificate that we're presenting. And this really provides that seamless interaction for the end user. And they don't even know that we will be doing deep inspection on this traffic, unless obviously you mention it to them. So that's kind of the benefits of using FortiClient. So we can also limit access to our virtual IPs using ZTNA tags. So this is not necessarily just for internal segmentation traffic. We can also enable it for traffic coming into our network from the outside world. Now, a good example of this is, I host my own EMS server. So I want to be able to access the management interface of EMS from, wherever I'm working from, but I don't want that to be available to the whole world. So I can actually use the all address object to match my source, and then I can match it with the ZTNA tag. So now it's secured to only my device that's connected to my EMS server and is presenting that EMS tag to my FortiGate. So the FortiGate monitors changes to the endpoint tags that are updated by EMS. And when a change is detected, the endpoint's active ZTNA sessions must match the ZTNA policy again before data can pass. So every time you access a new website, so in this instance, it's ems.demo.com, there's a check that happens. The user then accessed crm.demo.com. Now, in this example, something's gone wrong and access has been denied. Now, let's assume that, that user now has a malicious file on their PC. Well, then when they go to the next page, like the refresher page for ems.demo.com, or, they've clicked on a link inside, that check will be rerun, and that device will then be denied again because they've got a malicious file on their device. I'm going to hand back over to Kieran, and feel free to ask any questions in the chat box.
Thank you, Brendon. Sorry, let me just catch up to where we're up to. All right, ordering information. So Fortinet's ZTNA solution is supported across all of the FortiGate models, meaning that you get the same user experience from a technology standpoint, regardless of if you go for a small unit all the way up to their larger hardware appliances, or you're deploying a FortiGate VM. The only difference is the capacity and throughput that each model can handle. Generally, when you're scoping a FortiGate for ZTNA, you want to pay attention to the SSL inspection and the threat protection throughput numbers, as well as make sure that the device has the appropriate physical interfaces required to connect that FortiGate to the customer's network. When it comes to licensing, we would recommend that you look at purchasing the FortiGuard Enterprise Bundle license when you're purchasing a FortiGate for ZTNA, just to ensure that you aren't leaving out any of the pieces of the security puzzle. Here's a list of the main SKUs for FortiGate. This is not all inclusive. This is just the majority that we see of customers that are looking at deploying ZTNA. And the customer doesn't have a FortiGate. These are sort of the main ones that customers are looking for. But if you want to know more about, exactly what licenses are required for it, and you want to quote, just reach out to our support team, our sales team, and they'll be able to fill you through with, exactly what the requirements are. From a FortiClient perspective, which is our ZTNA agent, this can be either provisioned on a per user or a per endpoint basis. And it can be either managed from a cloud-based SaaS console or an on-premise solution, depending on what your customers' requirements are. There are additional managed services options to sort of assist with the initial setup, user onboarding, upgrades, and other operations, and that's called the Managed ZTNA agent. And for a list of all the available options in their SKUs, there is a FortiClient data sheet and a FortiClient ordering guide that is a lot more sort of inclusive than what we've got on the screen. But if we go across to the SKUs, these are the sort of main ones that we see customers looking at purchasing when they're looking for ZTNA. Now on this front, you can purchase with either a 1, 2, 3, 4, or 5 year license duration, if you'd like. And there's a range of different license options available. So ZTNA agent is the minimum. And then there's also the EPP agent, which provides that antivirus functionality on top of the base ZTNA functionality. Again, if you'd like more information about exactly what the licensing are that you require, just let us know. FortiAuthenticator, which we haven't spoken about much during this presentation, because the next webinar that we're running is focusing exactly into FortiAuthenticator and how it fits within the ZTNA solution. Just as a high level, it's available as a hardware appliance, a virtual machine, public cloud, and also a sort of FortiAuthenticator cloud, but it's actually called FortiTrust Identity. The hardware appliances and VMs are fully functioned offering, while the FortiTrust identity is still working on some of the features, such as radius functionality, to get it in line with the VM and the FortiTrust identity. The VM and hardware appliances. If you want more details about FortiAuthenticator, please feel free to join us on the next webinar where we dive in and do a lot more deeper focus on FortiAuthenticator. Now, we've only touched the surface here to sort of give you guys a little bit of information about the ZTNA solution and how it works for internal segmentation. If you'd like more information, there's plenty of resources at your fingertips as a Fortinet partner. There are solution briefs, there's marketing campaigns, there's data sheets, there's also ordering guides, and a lot of this information is available on the Fortinet main website and also the Fortinet partner portal under the asset library. For anyone that is NSE 4 and above certified, you can also register for the FortiDemo solution, and this allows you to go in and use a full fabric setup environment and go in and actually test whether you want to test the exact topology they provide you, or go in, nuke it, redesign it for what you would see for your customers, and try and test the ZTNA solution to a solution that would work for you. This is completely free for anyone that's NSE 4 and above. So if you don't have access to it, we highly suggest jump out and have a look at it. It's at fndn.fortinet.com. And of course, if you guys ever need any help or questions about ZTNA, you're always welcome as well to reach out to us. We're available, always. With that, we'll open up to the Q&A. Brendon, if you're still with us.
Sure am.
Perfect. So I've got one question here that says, can you use the all addressed object on the incoming policy, I'm assuming they mean firewall policy, when you're using ZTNA tags?
Absolutely. So when you are working with firewall policies, there's two different segments. You've got a matching part of the policy where we match the source interface, the destination interface, the source address, the destination address, and then the port number. Now, and then the second half, which is the web filter, the application control, the DNS, that's where we filter the traffic. So because we're matching it, when we match when we use the ZTNA tags, we're going to do a match on that. So therefore, because we are matching, the firewall policy will only allow traffic from the devices that match that ZTNA tag. Otherwise, it will just skip over that firewall policy and then go to the implicit deny. So by using the all address object, your traffic is still secured because we will never match that ZTNA tag if it's not registered to EMS and the client is not reporting as healthy, or whatever tag you are using.
Perfect. We did have a question about the minimum license level for ZTNA. So I'll go into it a little bit further. So the ZTNA functionality itself is included with the FortiGate. There's no license to be able to utilize the ZTNA functionality. It's more a question of, would you like to use ZTNA functionality and apply security policies to it? So if you wanted to do things like IPS on the traffic that's going through your ZTNA rules, then you would need a FortiGuard subscription with the IPS package to be able to utilize that IPS functionality. So that's why we're sort of recommending the enterprise level, because that gives you access to almost all of the FortiGuard subscription services as part of the FortiGate, to make sure that you're not just applying the ZTNA solution, but you're also applying security functionality with your ZTNA rules. There's one last question through. How would external port and vulnerability scanners respond to a ZTNA protected external IP with the all IP address rule applied?
Sorry, I'm just rereading that to make sure I understand the question. How external port and vulnerability scanners respond to ZTNA protected external IP. So I assume you're talking about the vulnerability scanner inside of FortiClient. So if FortiClient picks up a critical vulnerability, or it could be a high vulnerability as well, it really comes down to how you want to match or use that ZTNA rule. You could have a filter on if there's a critical vulnerability, then match it as, oh, sorry, you mean pen testing. Okay, sorry, I'll finish what I was saying and I'll jump to pen testing. So yeah, you can match that critical vulnerability and then deny traffic based on that critical vulnerability. Now, in terms of pen testing, so if the pen tester is not using an EMS connected device, then that firewall policy will not be open to the pen testing server or service, and they will just hit the implicit deny. They won't even know that that service is open. If they are using the allowed device, so the one that's connected to EMS has a tag, then that service will be open to that device and the pen tester will be able to penetrate the firewall using that service. But that's kind of by design. So I wouldn't include that as a vulnerability. I hope that answers the question.
Perfect. Alrighty, with that, we'll jump across to the rest. If there's any questions that we haven't gone through, we'll try and respond to after the webinar. So to help you get on the road to success, we've put together sort of 5 next steps for you guys to go through. The first would be to register for the upcoming ZTNA webinar around identity authentication. Again, that's the FortiAnalyzer piece. FortiAuthenticator piece. So definitely come along to that. We'll go really deep dive into how FortiAuthenticator plays within ZTNA and how you can use external authentication servers to make sure that you're utilizing whatever solution you have for access control. And then the second thing would be to reach out to your account manager here at Wavelink to arrange further discussion with our pre-sales team around exactly how the ZTNA solution would work for your customers. Third would be to run an internal demo to gain that first-hand experience with developing the ZTNA solution. So things like creating the ZTNA tags, looking at what your options are in there, because it's quite vast and there's a lot of things that you can use to create your tags to make sure that you're tagging against something that you actually want, whether it's antivirus enabled or domain joined. There's a whole array of options that you can choose there, and the tags can get really, really powerful if you want them to. And then of course, using those tags in your firewall rules to restrict your access rights. Then once you've got the hang of that and you understand how to do it from your internal demo, you would look at then running a demo for your prospective customers to highlight to that customer exactly how the ZTNA solution provides that sort of secure and convenient network access and segmentation. And then finally, once you know exactly how to deploy it into the customer's network, it would be then, selling a converged Fortinet security platform with ZTNA integrated that is designed to work well exactly for your customers, and you know all those ins and outs because you've gone through and you've actually deployed it and you know exactly how to run it. Otherwise, thank you guys so much for attending. If you have any questions, please don't hesitate to reach out. Otherwise, we look forward to seeing you in the next webinar. Thank you so much for coming.